Hello students, welcome back. Today we'll continue with the 13th video lecture of chapter number 9, Ray Optics and Optical Instrument. Till our last video we had solved some examples related to thin lens, right? Now today we'll start with refraction through a prism. Right now, refraction through a prism, it is a lengthy topic, very important topic. It can be asked in 4 marks in the board examination. Okay, now we will split it in two parts. First, we'll derive till prism equation, right? And then we'll find out the formula for refractive index of a prism. Okay, so now first, let's start with the prism. Okay, so let's take this prism A, B, and C. Name it. It's prism A, B, and C. Right now, let's take an incident ray. Let PQ be the incident ray. Okay, PQ is incident ray. Now we have to select a normal. So let this be the normal. Okay, let's select this as the normal. Okay, so now this is angle of incident I. Okay, now this ray was moving in this direction, but as it is changing the medium from air to prism, it will deviate. Clear? So now the angle made this is angle of refraction. Okay, now say here the medium is air N1 and the refractive index of prism I am taking it as N2. Clear? So now N1 will be equal to 1 and let's take N2 is equal to N. N be the refractive index of prism. So PQ incident ray, QR refracted ray. As it is entering from medium of lower refractive index to higher refractive index, it bends towards normal. Now, when it emerges outside the prism, means from prism to air, again it changes the medium from higher refractive index to lower refractive index, so it will bend away from normal. So first, let us draw a normal. This is the normal at point R. Okay, so what will happen? It will bend this away from normal. This is the direction in which it was moving actually, and this is the emergent ray. Let's name it as S. RS is emergent ray, so this will be the emergent angle. Clear? Let this be R2. Sorry, my mistake. This is not the emergent angle. This is the emergent angle. Sorry, yes, that was the emergent angle. Away from the normal. Okay, let this angle be R2. Okay, now see, when I extend these ray backward, I got this angle and I will name it as delta. Means the original ray incident was moving in this direction and the emergent ray is moving in this direction. Clear? So this is the total deviation delta. Clear? Now what is the deviation for the incident ray? Incident ray was moving in this way and this is the refracted ray. So this is delta 1. Okay? Refracted ray was moving in this way and the emergent is this way, so this is delta 2 and this is vertical opposite angle, so I will name this also delta 2. Clear? So let me write it down clearly. This angle is delta 2. Okay, so now this is the figure. You need to explain the figure in the descriptive portion. Write down, let PQ be the incident ray, QR be the refracted ray, and RS be the emergent ray. I angle of incident, R1 angle of refraction at point Q, E angle of emergent, delta 1 that is angle of deviation of incident ray, delta 2 of the refracted ray, and delta is the total deviation. A is the angle of prism, or I will name this as prism angle. Clear? So this was about the figure. You need to first explain this figure. So first, let's derive prism equation. Now, let's take polygon A, Q, L, R. Let's take this correlator A, Q, L, R. Okay. In correlator A, Q, L, R. Now see, this KL is normal, so this angle will be 90. And again, RL is the normal, so this angle will be also equal to 90. Now we know that summation of all the angle of a quadrilateral is 360 degrees. So if these two are 90 plus 90, 180, so angle A plus angle L, this will be equal to 180. So angle A plus angle QLR equal to 180 degree. Okay, now let's take this triangle QRL. Okay, I am taking triangle QRL. This angle it's R1, this angle it's R2. Okay, so in triangle QRL, summation of all three angles of a triangle is 180. So R1 plus R2 plus angle QLR equal to 180 degree. Right? Now, when I compare these two equations, see here also it's angle QLR, here also it's angle QLR. And in both the case, RHS is 180. So what does this mean? This means that angle A is equal to R1 plus R2. So from here, from 1 and 2, I can write it down angle A equal to R1 plus R2. Okay, now remember this is very important formula. Okay, the prism angle this will be equal to refraction angle 1 plus refraction angle 2. So R1 plus R2. Okay, now taking triangle. Okay, now taking triangle, this triangle. Okay, let's name this as T. And this is delta 2. So taking that triangle T, Q, R. Okay, when I take this triangle TQR, say this is the triangle TQR. This is delta 1, this is delta 2, and this exterior angle is delta. Now remember a property of triangle. Sum of two interior angle is equal to the opposite exterior angle. So this means sum of two interior angle delta 1 plus delta 2 is equal to the opposite exterior angle. And what is delta? Delta is the total deviation. Okay, so now see delta 1. If I see in this figure, this is angle of incident I, and this is its vertical opposite angle, that is delta 1 plus R1. So delta 1 plus R1 equal to I, that implies delta 1 equal to I minus R1. Okay, if I take this side, this is the emergent angle and this is the vertical opposite angle. So this is delta 2 plus R2. Delta 2 plus R2 equal to E. That means delta 2 is equal to E minus R2. So putting the value of delta 1 and delta 2 in this equation, I get I minus R1 plus E minus R2, that is equal to delta. So I plus E, I will take minus common, R1 plus R2 equal to delta. Now what is R1 plus R2? Prism angle A. So I plus E minus A equal to delta, or I plus E equal to A plus delta. Clear? This is the equation of prism, okay, or I can say prism equation. How will you define prism equation? The equation giving relationship between angle of incidence, angle of emergence, prism angle, and deviation is called prism equation. So if I want to define it, I can say that equation giving relation between angle of incident, angle of emergence, prism angle, and deviation, that is prism angle. Okay, so I'm repeating the whole topic. If the question is asked, derive prism equation in 4 marks, then how you have to start? First, draw this complete diagram and then explain the diagram as shown in figure. Let PQ be the incident ray, QR refracted ray, and RS emergent ray. I angle of incident, R1, R2, that is angle of refraction, E angle of emergence. Clear? Then delta 1 angle of deviation, delta 2. See, remember, this is the emergence angle. This angle is emergent angle. Clear? This is not the emergent angle. Okay, delta 1, delta 2 are the angle of deviation for incident and refracted ray. Delta is the total deviation, A angle of prism. Outside's air, so refractive index is 1, and let the refractive index of the prism is n. Now first take correlator AQLR. From that I get angle A plus angle QLR 180 degree. Taking triangle QRL, I get R1 plus R2 plus angle QLR equal to 180. Solving 1 and 2, I get A equal to R1 plus R2. Remember this step, this is important. Prism angle A equal to R1 plus R2. Now taking this triangle TQR, I got sum of two interior equal to exterior, that is delta 1 plus delta 2 equal to delta. I found out the value of delta 1 and delta 2, put it here, and finally we get I plus E equal to A plus delta. That is prism equation. Equation giving relationship between angle of incident, angle of emergence, prism angle, and deviation is called prism equation. Here, so just note down till here. Now, let's see about angle of minimum deviation. Now see, this is a plot, a graph of angle of deviation versus angle of incidence. Now it is observed that as you go on increasing the angle of incidence, the angle of deviation decreases. See, I am increasing the angle of incidence, the angle of deviation is decreasing. Right? After one point, again increasing the angle of incidence, the angle of deviation increases. So from this graph, it is seen that at two values of angle of incidence, if I take this as I1 and this as I2, in both the cases, the angle of deviation is same. So for two angle of incidence, the angle of deviation will be same. Now the reason, see, if angle of incidence is 50 degree, in that case, if angle of emergence is 30, then when angle of incidence will be 30, at that time angle of emergence will be 50. Let's take, see, if I is equal to 50, if in this case E becomes 30 degree, then when I is equal to 30 degree, at that time I will be equal to 50 degree. So in both these cases, the angle of deviation will be same. But in one case, when I will be equal to E, at that time the angle of deviation will be minimum. Okay, so remember, when I is equal to E, delta is equal to delta M, that is minimum deviation. Clear? So now, see here, at I equal to E, delta equal to delta M. Now, in the previous derivation, I had just shortlisted two formula. One, this was the Prism equation, I plus E equal to A plus delta. And before that, we got this R1 plus R2 is equal to the Prism angle A. So if I put this value, delta, okay, what was delta? Delta 1 plus delta 2, that is I plus E, sorry, here. So if I put this delta equal to delta M in Prism equation, what I will get? See, I plus I. Why I? Because I is equal to E. I got A plus, instead of delta, delta M. So I plus I, 2I equal to A plus delta M, or else angle of incidence, this will be equal to A plus delta M by 2. Okay, this is also important equation. When the deviation is minimum, at that time the angle of incidence will be equal to A plus delta M by 2. Clear? So second, now note down this. Now, the last part of this topic, that is refractive index of a prism. So question can be asked in 4 marks, that using the equation of prism or using prism equation, derive the equation for refractive index of prism. So first, let's write down the prerequisite formula, like when there is minimum deviation, when delta is equal to delta M, angle of incident equal to angle of immersion, and A is I plus, sorry, yes, I is equal to A plus delta M by 2. Clear? And also one more formula, R1 plus R2 is equal to A. So now, when I take Snell's, when I apply Snell's law at Q and R, applying Snell's law at point Q and R. Okay, see at Q, N1 sine 1 equal to N2 sine R. So what is N1? 1. Or let me write down N1 sine I equal to N2 sine R1. This is angle of refraction. So N1 that is air medium, so 1 sine I equal to N2 that is N sine R1. Okay, next at point R, we have to use N2 sine R2 that is equal to N1 sine E. Refractive index N2, angle of incidence R2. So N2 sine R2, refractive index N1 and angle of refraction E. So this will be equal to N sine R2. This is equal to sine E. Clear? But see, I is equal to E. But I is equal to E. So that implies sine I equal to sine E. When I compare these two equations, here it's sine E, here it's sine I. So N sine R1 equal to N sine R2. And then gets cancelled. So we get new thing R1 equal to R2. Okay, and let's take this as R. Okay, I have taken R1 equal to R2 equal to R. Now if I take here R plus R A, right? If I put this here R1 plus R1 equal to A, that means from equation R1 plus R2 equal to A, I get R plus R, that is 2R equal to A. That implies R is equal to A by 2. Here R is equal to A by 2. I also have angle of incidence I is equal to A plus delta M by 2. So now when I take this Snell's law at point Q, okay, when I take this equation, what is N1? 1. What is, let's place first sine I equal to N2. What is N2? N sine R1. Okay, and what is R1? We have taken it R. So N is equal to sine I upon sine R. Now we had already found it out that at minimum deviation, I equal to A plus delta M by 2 and R equal to A by 2. So N is equal to sine A plus delta M by 2 upon sine A by 2. This is the equation for refractive index of a prism. Clear? I'm repeating where I started. First, I had taken the prerequisite formula that when at minimum deviation I equal to E, angle of incidence R1 R2 equal to R1 plus R2 equal to A. I have applied Snell's law Q and R. From that, I got sin I equal to sin E. That means n sin R1 equal to n sin R2. So I got R1 equal to R2 equal to I. Putting this value in this, I got R equal to A by 2 when there is minimum deviation. So again taking this Snell's law, putting value of I and R, I got N equal to sine A plus delta M by 2 upon sine A by 2. Clear? So just note down this topic. Now, in this equation of refractive index of prism, we have taken the surrounding medium as n. So it was n equal to 1 and the refractive index of prism that was equal to n. But now if I take the surrounding medium as some other liquid, right? Then the formula becomes instead of n, n to 1. That is refractive index of 2 with respect to 1 that is n2 by n1 equal to sine a plus delta m by 2 upon sine a by 2. This becomes the equation of refractive index, means refractive index of 2, that is the medium of prism with respect to the surrounding medium. Clear? So remember that minimum deviation delta m depends on, first, see, angle of prism, means prism angle. Second, refractive index 2, and 2 means refractive index of the material of the prism. Third, n1, that is refractive index of the surrounding. So remember these 3 points. The minimum deviation delta m depends on angle of prism, refractive index of the prism, and refractive index of the surrounding medium. Clear? Now if I take a thin prism, clear? Now see, this is the angle of prism, it's larger. But if I take a thin prism, means where the angle of prism is very less. Clear? So what will be the case in that case? Okay, what will be the formula for refractive index in this case? Now we know that when angle is very small, sine theta equal to theta. So in this formula, instead of sine a plus delta m by 2, I can write it down a plus delta m by 2. Right? So here n will be equal to sine theta equal to theta. So I can write down theta. So it's a plus delta m by 2 upon, instead of sine theta equal to theta, a by 2, a by 2. So 2 gets cancelled, this 8 divided, and a will be equal to a plus delta m. So delta m will be equal to Na minus A, or delta M will be equal to A into N minus 1. This is the formula for deviation when we use a thin prism. Remember, what is thin prism? When the prism angle is very small, such type of prism, we call it as thin prism. So this will be the deviation, right? Now when you see that when a white light is passed through a prism, let's take, I'm taking a thin prism, okay? When a white light is passed, okay, when a white light is passed, what happens? It deviates, clear? When a white light is passed, it deviates in the prism, and then we get 7 different colors, okay? So when we get 7 different colors like this way, this violet, this red, right? See, what you observe, which light has deviated maximum? Violet light, and minimum red light. This is because the refractive index of red light is very less compared to violet light, right? Relatively, the refractive index of red light is less, so it deviated less. And for violet, it is higher. So using this formula, we can say there will be higher deviation. Clear? So just note down this. Okay, students. So that's it for today. Today we have completed this topic of refraction of a prism. Right? We have derived the equation for prism. Then we have taken a graph for minimum deviation. We have derived the refractive formula for refractive index of prism, and then the formula for deviation when we take thin prism. So that's it for today. Thank you.